We've looked at the concepts of setting up static routes. Let's take a look at the implementation. Let's jump into Packet Tracer and actually do some of the config. When we look at this structure, what do our routers know about? Again, we're doing IPv4 static routing here. So my router R1 knows about the 10 network and the 20 network. My router R2 knows about the 20 network and the 30 network. R2 does not know about the 10 network. R1 does not know about the 30 network. So if I were to try to send a packet from PC1 to my server, it shouldn't get there. We can actually see this. It might be interesting to actually take a look at how this works. So in Packet Tracer, I can use a simulation mode. In the simulation mode, we can actually watch the packet go from point A to point B. We can watch the whole thing work. So let me grab my PC1. And what I'm going to do in PC1 is do a ping out to my server. So I'll do a ping 192.168.30.200. And in simulation mode, what that does for me is that starts the process. And now we can see our packet sitting here. So my little purple packet is my ICMP packet. But my PC has no knowledge of where the destination is. I tried to ping 192.168.30.200. My PC said, oh, that's not my network. I need to send this to the router. My default gateway is 10.1. Oh no, I don't have a MAC address for 10.1. What do I do now? So what the PC is going to do is it's going to send out an ARP request for the MAC address of the router. So the MAC address, the ARP request is a broadcast. It goes into the switch. It goes out all ports except the one it came in on. The MAC address we're asking for is that of 1.1, so the laptop goes, hey, that's not me. But the router turns around and says, hey, that's me. Hey, PC1, here's my MAC. Sends it back down as a directed send. It only goes back to PC1. Now that PC1 has the MAC address of the router, it can actually send the packet to the router, which is the ICMP ping packet, or the echo request, for the server at 30.200. The destination is 30.200. When the router gets it, the router has no knowledge of where 30.200 is, so the router is going to discard the packet, and then it's going to send an ICMP message back to the originating station that says, your destination is unreachable. That's that little red box going back down there now. Once the PC gets it, it can turn around and go back out and do the same thing. So if I go back to my PC now, you'll see that I actually have this message from my router, reply from my router, your destination is unreachable. So the whole process allows us to see that what's actually happening on our network. So how do we fix this? How do we make this work? What I need to do is go into router 1 and tell it where the next hop is, how to get there. Again, remember that my routing is always next hop. So what I really want to do is tell router 1, hey router 1, if you see a packet destined for the 192.168.30 network, I need my subnet mask if I want to say the word network. Where does it need to go? It needs to go to this next hop interface. So you need to send that to 192.168.20.2. Hey router, if you see the 30 network, get the MAC address and send it here. How do we do that inside the router? How do we actually make those changes? Well, it's not all that bad. Let's jump into router 1 and see. In router 1, let me get rid of that. All that extraneous text, we don't need this. In router 1, my password for my console line was console. Enable, my password is Cisco. I was hoping. For router 1, I want to create that static route. So I'll go into global config. Now a static route is going to be a global configuration. It's going to affect the whole router. So now I need to say, I want to create an IP route. So what command will I use? Would you believe IP route? Hey router, if you see the 192.168.30.0 network, got to put my mask in, that makes me say network, where do we want it to go? 192.168.20.2. Is that right? If we see the 30 network, send it to 20.2. Yeah, that works. Let's do an enter. Do show run. So I can see my running configuration. Sure enough, there's the IP route statement that we just put in, exactly as I typed it. What if I want to see it in my route table? This is what the router uses, the IP route table, so I want it to show me its IP route. do show IP route. This actually now shows me that I have a route for the 30 network. Hey, if I see the 10 network, it's going to go out the fast Ethernet interface. If I see the 20 network, it's going to go out serial 00. If I see the 30 network, send it to this machine. Will it work? If I go back and do my simulation again, and I actually try to do my ping from my PC, what do you think? Ping 30.200. It hasn't been more than 2 minutes, so I'm not going to do an ARP request again because my ARP cache is already going to know the MAC address of the router. So I'm just going to send the ICMP message up to 30.200. From my PC to my switch, it's got the destination MAC address of the router, so the switch forwards it only to the router. The router gets it, goes to its IP route table, goes, hey, I know where that goes, and sends the packet to R2. R2 is connected to 30, goes, hey, I know that, hey server, give me your MAC, and it sends the packet to the server. What's the server going to do now? It's going to send an ICMP echo reply back to my PC. But the problem is, when it gets to router 2 is going to drop the packet. Why? Because router 2 has no idea where the 10 network is. Now you might say, but the packet just came through router 2. Why doesn't router 2 look at the headers? Because that's not how routing works. The switches look at the MAC address header. They learn the ports and the MAC addresses, but routers don't learn anything. They have to be told. So just because the packet came through in the first place doesn't mean it can find its way back. Ultimately, what that means for you and me is we have to put a second route in here so that R2 can know where the 10 network is. So if we want to make it work, well, I suppose we can jump back to PC1 and see we got timed out messages here. Yeah, that's exactly what's going to happen. Now, what about that ICMP message? Why don't we see that? Because the ICMP message that's being sent is actually being sent back to the server, right? The destination unreachable message from R2 is going back to the server. We're not looking at the server, we're looking at the PC. So we have two different messages. If our router doesn't know where the packet goes, it sends me a message and says, hey, I don't know where you want me to send this. If the second router or some other router, third, fourth, fifth, I don't care what router it is, some other router is making a message on a packet on the way back, it's going to send it to the sending station, which would be that server that was replying. So we need to go into our router 2 and actually do that same type of static route. Router 2 is going to be conf t. We need to tell the router, hey router, if you see a packet destined for the 192.168.10 network, and that line right there is the 10 network, then you need to send your packet to 192.168.20.1. Is that right? Let's look at our diagram. So, hey R2, if you see a packet destined for the 10 network, you need to send your packet to 20.1. Is that what I typed? 20.1? I did. So this should work for us. Do show IP route. I now see that I have a static route that says, hey, if you see the 10 network, send it to 20.1. So I should actually be able to communicate now. My PC over here should be able to do, well, let's do simulation mode so we can watch it go. If I do that same command again, ping 30.200, no ARPs required, up to my router, over to router 2, down to the server. Server says, hey, I'll send this back to you. ICMP echo reply back to the switch, to the router, and the router does a lookup, and it sends it to router 1. Down to the switch, down to the PC. If I go back to my PC prompt, I should see a reply from, everything is good. So again, back in real-time mode, back to my PC. There's my 4 replies. We now have full connectivity. We have set up a static route to give me full connectivity across my network. Again, a very small infrastructure here, just 2 routers. Statics are perfect for this environment. You wouldn't want to do this for 900 routers. But for 2, it works perfectly well. Static routing implemented.